Hi everybody, this is Mr. Schaefer. I'd like to present to you today the third form of quadratic functions, which is called vertex form. We have standard form, we have intercept form, and now our third form today is a form that's going to allow us to identify the vertex pretty quickly and also allow us to transform the parent function, the general function of f of x equals x squared, sort of your basic parabola. We're going to move this, shift this parabola up and down and left and right across the coordinate plane. So to start off, we have just the general x squared function, and I'm going to go over to Desmos and show you a picture of y equals x squared. Now on our first question right here, we have sketch the graph of x squared plus 2. So for x squared plus 2, let's take a look and see what that does. So I'll type it in Desmos. In green, you can see the parabola of y equals x squared plus 2. Notice that every single point on my parent function seemed to get shifted up 2 units. So this x squared plus 2 moved the parabola up by 2. Letter B says, sketch the graph of x squared minus 3. Back into Desmos. Let me turn off this one here and change it to x squared minus 3. So now, the parent function again is the blue, but take a look at where the x squared minus 3 parabola currently exists. It's below the origin of 0, 0. All the points seem to have gotten shifted 3 units down. And I can illustrate this all by simply adding kind of this generic constant. I'll call it k. And I'll add a slider here on Desmos. And what this is going to allow me to do is I can actually make k any value I want. X squared plus 9, x squared plus 5, x squared plus 3. X squared minus 1 will make k equal to negative 1. Or x squared minus 4. Make k equal to negative 4. And so what we can do is I can animate this, and I can just look at a number of different k values to see what that k sort of controls about the parabola and where it transforms or moves or shifts this quadratic function. So as you can see from this animation, that this k value that we're kind of adding on the end of the x squared piece is just going to move the parabola either up or down depending on what that value is. So let's come back here to this note page and we'll fill in a couple ideas. Sketch the graph of g of x, x squared plus 2. I'll do that in red. We're going to shift all these points up 2. So here are the new points, and there's the new quadratic. We'll call that g of x. Changing colors right here, we'll go to green, and it says sketch the graph of, again, x squared minus 3. So in Desmos, we saw that that's going to pull these points down by 3 units. 1, 2, 3. There's my new vertex. These guys also down 1, 2, 3, and 3. And so our parabola is kind of taking a shape like that. Call that h of x in green. Now I'm going to skip down here to the generalization because we saw some of the animations on Desmos kind of help us draw these conclusions. Generalization, when a number is added or subtracted outside of the x squared, and that's actually a key idea, then the vertex of this parabola is going to move up when added, write the word up, when added, and then down when subtracted. Up when added and down when subtracted. X squared plus 2, that's a transformation up 2 by all of my points. X squared minus 3 is a transformation down 3 of all of my quadratic or parabola points. Now, There's another kind of transformation, and that's actually a horizontal shift. Let's take a look at our x squared function once again. And I'm going to type something in a little bit differently when I go here to Desmos. So I'll clear away these values. Let's go back to looking at just the generic parent function, y equals x squared. Now, rather than doing a plus or a minus on the outside of that x squared, look at letter A right here. Sketch the graph of quantity x plus 2 squared. So my plus 2 is now on the inside of what is being squared, and that matters when I go to write or to type things into Desmos, or when I go to type things in on my parabola or my calculator to view the parabola. So here's the graph of x plus 2 quantity squared. My question for you would be, where did the parabola go? Again, let's do this. Let's keep the parent function open here in Desmos so that you can see what the parent is, where the original is, and then down here again, I'll put that transformed quadratic function in here like that. So the black sketch that you see here is the transformation of quantity x plus 2 squared. The blue is my parent function of y equals x squared. Where did it go? Where is this black parabola sketch? It's to the left of the one that we started with. And more specifically, how far left? 1, 2. 2 units to the left of the origin is that transformation. The next one here says to sketch the graph of x minus 3 quantity squared. So let's do that. Y equals x minus 3 quantity squared. I'll turn off that first transformation. Here's my blue parent function. And then now I have x minus 3 quantity squared. Where did that parabola shift over to? We're not going up or down like we did earlier. This kind of transformation is actually a left versus right transformation. So notice that this x minus 3 squared now fell 3, this whole parabola got shifted 3 units to the right of the origin. The vertex is 3 units to the right. Every point on the parent function is shifted 3 units to the right. And again, I'll do one more thing. Let me change this to just a little constant there. We'll call that h, and I'll add a slider so that as h can be any different number. When h is negative, look at where the parabola is. The parabola lives or gets shifted to the right of my parent function. If h is positive, like positive 5.5, positive 7, or positive 8 or 9 out here, look at where that parabola transformed. It's now to the left of my parent function. So we have 2 transformations. This transformation is a horizontal, left or right shift, and the one that has a plus or a minus on the outside of your x squared is going to shift the parabola up or down. So let's go back to our paper and we'll fill in those conclusions. X plus 2, that's going to be a shift to the left by 2, as we saw on Desmos. It's a little bit misleading because we see the plus sign, and doesn't the plus sign or a positive marker mean we're going to go to the right? Well, not exactly. It's actually the very opposite. We're going to shift this thing left by 2. So here are all my points, the 5 points, being shifted to the left by a value of 2 units. Change colors. Sketch the graph h of x. X minus 3 quantity squared. Well, that's going to be a shift to the right by 3. And again, look how it's a minus in there. Minus typically in mathematics means negative or left, but it's the opposite when we have a horizontal shift. So x minus 3 quantity squared means we're actually shifting all of these points to the right by 3 units. So in green, there's my sketch of h of x. And in red, is the sketch of g of x. I'll skip down once again to the generalizations. We saw kind of what's happening here with Desmos. When a number is added or subtracted inside of the x squared, then that's going to shift the vertex horizontally. More specifically, the parabola is going to move to the left when we have addition, and then we have a right shift or right movement when there is subtraction. So let's see if we can now apply those concepts and those generalizations to making a graph of a parabola on our own here. Number 3, identify the vertex and then graph the function j of x equals x minus 4 quantity squared plus 1. Look at the transformations here. The first one is a transformation to the right by 4. And then this little plus 1 out here is a transformation up by 1. So we have a horizontal transformation and a vertical transformation. If you move everything to the right by 4 and then up by 1, you have the new vertex. Our vertex is simply positive 4, comma, positive 1. You can see the vertex directly in vertex form of a quadratic equation. The only thing that's kind of tricky to remember here is that for that x coordinate, we actually want to use the opposite. You see an x minus 4 right there inside of what's being squared. It's the positive 4. It's the opposite of the negative 4 that we want to use. Here on the outside, we see positive 1. There is no change in the sign. If it's plus 1, the y value is positive 1. If it's minus 5, the y value is negative 5. There's no change. The only change that occurs is within that horizontal or x coordinate of the vertex. Now that's great for the vertex, but we need the other points. Let's put the vertex in the middle of our table. So 4, comma 1. And I'd recommend going maybe 1 or 2 points in front of the vertex, and then 1 or 2 points behind the vertex as well. So you could go out to 6, 4, 5, 6, and then 4, 3. You could get a 2 if you wanted to in there. That would give us a total of 5 points. And 5 points to graph in the parabola would be great. I think we can get this with 3. And by the way, notice that the axis, once you have this x coordinate, the axis of symmetry is going to also be x equals that same number. So I'll graph the axis of symmetry for us. And then to find the matching y's for 3 and 5, we would just plug those numbers in to our function. So let's find what happens if I plug in 5. So j of 5 would be 5 minus 4 quantity squared plus 1. And then j of 3 would be 3 minus 4 quantity squared plus 1. Well, I'm going to have 1 squared, which is 1, and then 1 plus 1 is 2. Here I'll have a negative 1 squared, which is still 1, plus 1, which is still 2. So both of these outputs are 2. 3, comma 2, 5, comma 2. And we're starting to see the shape of our parabola take place. There it is. So vertex form, again, here's what the sort of skeleton looks like. Our third and final form for quadratic equations. Notice that there is still the a value. The a value in front, that leading coefficient, is going to control whether the parabola opens up or down. The vertex can be found by looking at h and k, those little constants that are in vertex form. And remember that for that h value, it's really the opposite of what you see that goes in there for x. For k, it's the regular number that you see. So opposite number and regular number. Axis of symmetry will be x equals, in this case, h. It's going to match the x coordinate of the vertex. And the a value, once again, controls whether the parabola opens up or down. hk, the vertex, should go in the middle of your table. And then just go in front of and behind that vertex to generate some more points. So that is vertex form of a quadratic function. It helps us kind of analyze what's happening with transformations of parabolas as they move and shift across the coordinate plane. And it's a great way to very quickly identify what the vertex is of a parabola.